I run the Novel Mobile Robots Lab in the Mechanical Science and Engineering Department at U of I, and our lab works on a lot of robots that move around in maybe slightly weird ways. We're really excited about exploring the different ways that robots can move around in the world, walking, rolling, jumping, maybe even slithering. Salto is a project that developed really big, powerful jumping motion, and it's now continuing into a project called LEAP, Legged Exploration Across the Plume, in which we're working with NASA to develop jumping locomotion for other planetary bodies. Specifically, looking at if we can make really, really big jumps on Enceladus, an icy moon of Saturn. There, with gravity 1/80th as strong as on Earth, a robot that can jump 4 feet high might be able to jump as far as like a football field in a single bound, allowing it to cover crevices and canyons and other really rough terrain. Other jumping robots include Pinto, a squirrel-inspired robot that we recently completed that looks at doing motion not just on flat terrain, but also transitioning from the ground up onto vertical surfaces like trees. Can we build robots that are faster and more efficient than Lego robots, but more agile, better able to climb stairs and get over rough terrain than robots with wheels? If we look at current robots today, a lot of really exciting Lego robots can tap dance and backflip and do all these really amazing things, but if we look at how good they are at doing useful things for us, like carrying a package a certain distance at a certain speed, it turns out that they're actually not very good. My career award is called Extreme Robot Walking, Speed, Agility, and Efficiency via Reduced Degrees of Freedom. This project is looking at trying to build legged robots a little bit more like the way we build robots with wheels and wings and propellers. If you count the number of motors or engines in a conventional vehicle, think a plane or a boat or a car, usually they have something between 1 and maybe 4 engines. But if you count the number of motors in a current legged robot, they usually have something like 12 to maybe even 30 motors. The penalty for having that many is it's heavier and they take more energy and power to run. As a consequence, these robots can't run for as long and they have to be a little bit slower carrying around those extra motors. If we want to make Lego robots that are faster and stronger and more efficient, I think we should see if we can use fewer motors in a way more like cars and boats and planes. So can we play to engineering strengths to build Lego robots that can do some things that legged animals can do, but also some things that animals can't? Can we make legged robots that can walk so quickly they can walk faster than a human can walk, maybe even as fast as a human runs? I think that would be really exciting.